You are a programmer using linear interpolation for your animations. That's what this line here is meant to represent. Your linear interpolation takes a number from 0 to 1 and maps it from 0 to 1 in the output. You find, however, that the linear interpolation looks awful. It's really not very professional looking. It's not smooth enough. It kind of looks like a PowerPoint animation. So you want something better. So you open up your web browser and you start searching the internet for some kind of smoother function. And you come across an old friend, the logistic function. The logistic function is great. It has a fantastic shape. It's got a smooth entry. It's got a smooth exit. It's got some shape parameters that change the steepness of the curve. It's a fantastic function. However, it's got one crippling flaw. If you input 0, you don't get 0. If you input 1, you don't get 1. There's these massive jumps at the start and end of the function that are a complete disaster and will not work at all. So you theorize that maybe you can do some fancy mathematical manipulations in order to shift it or stretch it or something like that so that it will line up properly. So the first thing you do, we come over here to this guy. You try shifting it downwards. Okay, we can do that simply enough. You just subtract some number. Okay, great. We can approximately get it to line up. But now we want to sort of bring this up to line up here. Well, you can do that. You put that, you add this at the top of the fraction, and you can just about get it to line up. Okay. Great. Well, except, I mean, it kind of like messed it up a little bit, right? Okay. And it turns out that for every shift down that you add, you need to do twice that to shift it back up to account for that. Okay. So you can kind of compact these two parameters into just one parameter. And you get the same idea. Okay, so if you do this, you'll stretch the function. Great. Okay, so we preserved the symmetry. We've got the stretching happening equally on both sides. And we can if we're eyeballing it, we can get it to line up, but it doesn't work for every shape parameter, as you can see. So what's the general solution for finding the value of A that will get this to line up perfectly, and so there's not a jump in your interpolation? What you can do is you basically you want to plug in 0 into your function here. Okay, 0 is the x value, and you expect 0 to come out of it. So you do that, and then you solve for the correct value of A that will give you that, given any shape, given any y max. Okay, and you get this basically. Okay, so here we go. You get this. This is a complete mess. It's not as complicated as it looks, though. Here it is, unsimplified. And as you can see, the solution works. It lines up perfectly, and it will work for any shape parameter as well. And here you go. Here's also the simplified version of it. And it also works for any shape parameter. So I hope this is useful to anyone trying to do a nonlinear interpolation and they really like the logistic function. This is how you can get it done. Good luck.